All right, in this video we're going to introduce transforming functions, and in particular we're going to look at vertical and horizontal shifts of the graph of a function. So for a function such as f of x equals the square root of x, we're going to determine what happens to that graph if we add or subtract a number to the function. So in other words, if we have the square root of x and then outside of the square root of x we have something like plus 5 or minus 3. So what is adding or subtracting a number outside of the function or after the function? How does that impact the original graph? Well, here we have f of x is the square root of x, and which is right here. G of x is f of x plus d. So right now d is 0, which they're the same because square root of x here plus 0 is just the square root of x. But now let's see what happens if we add a positive number to that. So here's the graph of, in blue, f of x is the square root of x and then a plus 1. So this would be the square root of x and then plus 1 afterwards. And then here we have when x is, or when we're adding 3.1 to our function. Notice all the y coordinates are going up by that much. So for instance, here we have on the original graph, we have when x is 5, the square root of that is about 2.236. When we do the square root of 5 and then add 3.1 to that, we get 5.336. So all the y coordinates get shifted up by whatever the value of d is. And if we reset this and make d equal to 0, now let's see what happens if we have f of x minus a number. Like here in blue is the graph of the square root of x and then a minus 1 after the square root of x. Over here we have the graph of square root of x and then a minus 4 outside the square root. So notice it took all the y coordinates and moved them down 4 spaces. In other words, we just subtract 4 from all the y coordinates. So it's a vertical shift and it's going up whatever the value of d units is, whatever the value of d is, that many units if d is positive, and it's moving down if it's negative. So like the square root of x minus 4, that's moving it down 4 units. And it's important to keep in mind that the number we're adding or subtracting in this demonstration here is not inside the square root, it's outside. So these are adding and subtracting outside of the function. So keep that in mind as we look at these transformations. It's all about location in terms of what you're doing to the original equation. So example 1, determine the effect on the graph of f of x equals the square root of x for each. So we have g of x is the square root of x plus 11. So going back to our original one here, if we kind of scroll up here, notice the red graph, the square root, is now moved upwards 11 units. So what happened to our function was we shifted it up 11 units. Notice again the plus 11 is not inside the square root of x. For part B, g of x is the square root of x and then minus 15. Well, this one is just going to get shifted down 15 units. So if it's outside subtraction, it's moving down that many units. All right, now let's see what happens if we add or subtract a number inside the function. So I'm just going to get rid of some of this here. And now we're going to have, we'll do plus c inside. We're going to add the slider. We'll start with c is 0. And just reset this here. Okay. So here we have the square root of x, and then we're adding a number. This time we would add it inside the square root. So for instance, here we have the square root of x plus 1, where the x plus 1 is inside the square root in blue. And notice as we keep adding bigger and bigger numbers, it pushes the graph further and further and further to the left. So right now in blue, we have the square root of x plus 5, where the x plus 5 is inside the square root. And if we reset this back to 0, if adding a number inside pushes it to the left, let's see what happens if we subtract a number. So if it's a minus, well, here's the square root of x minus 1 in blue, where the x minus 1 is completely inside of a square root. And notice the further we make it, the more we make it negative, the further to the right it pushes it. So if it's minus inside the function, it pushes it to the right. If it's plus, it pushes it to the left. And that's one of the tricks with these kinds of shifting, is sometimes when you change where you're adding or subtracting, it affects the graph in a much different way. So this is a horizontal shift, and if it's minus, it's actually going to the right that many units, and if it's plus, it's actually going to the left that many units. So notice the number again that we're adding or subtracting would be inside the function. So the plus or minus of the number would be still inside that square root. So example 2, determine the effect on the graph of f of x is the square root of x for g of x is the square root of x plus 11. So let's take a look at the square root of x plus 11. So we can just set that here. And if we zoom out a bit, in red is our original square root of x graph. In blue is the square root of x plus 11. And notice it took the red graph and moved it to the left 11 units. So going and adding inside the square root actually moves it to the left that many spaces, in this case 11 units. All right, finally, g of x is the square root of x minus 15, where this time the minus 15 is inside. So let's make this minus 15. And this time it moved the red graph 15 units to the right to get the blue graph. So if we analyze that, it's a shift to the right 15 units. So if it's outside the function, it's a vertical shift. If it's inside the function, it's a horizontal shift. And horizontal shifts are very counterintuitive. So if you think about if you point to the left, to your left, and someone is looking at you, they think you're pointing to the right, whereas you're pointing to the left. And if you point to the right, they think you're pointing to the left. So with horizontal shifts, it's the opposite. With vertical shifts, if you point upwards, then you both know from both your perspectives, you're both pointing, you can both tell you're pointing up. And if you point downwards from both your perspectives, you can tell you're pointing down. So vertical shifts go the way that it says with plus and minus. Horizontal shifts are the opposite. A plus actually moves to the left, a minus actually moves to the right. All right, so that about does it for this video. Thanks for watching, and I'll see you next time.